Hello. In the last lecture, we had seen how to create a decision tree using ID3 algorithm. Here we'll see using CART. What is CART? CART is an algorithm which creates classification and regression trees. And what is it? Like it creates only binary decision trees. If you remember in ID3, you had tree which could have had three branches also coming out from a node. For example, in case of Outlook, whereas in CART, you will have only two branches from every node coming out. This is the formula for CART. If we check out what are different notations mean. For example, if you have a node, the node might have a left subtree and a right subtree. So L says left subtree, R says right subtree. When you're talking about PL and PR, they are basically what? Any training node which you take, any record which you are taking, what is the probability that it will go in the left subtree? What is the probability it will go in the right subtree? So the formula for that is the tuples in the left subtree divided by total number of tuples, or the tuples in the right subtree divided by total number of tuples. What is this? If you remember, you had conditional probability. What does this say? That what is the probability that given the tuple is in left subtree, it will belong to class J, Cj. So this is the conditional probability that given an event has already happened. So example, they already know that it is there in the left subtree. Then what is the probability that it will be there in class Cj? Similarly over here, given it is in the right subtree, what is the probability that it will belong to class Cj? So this is what tuples of class J in either left or the right subtree for this and this divided by tuples at the target node. So if you try to understand this using an example, so this is a case where we have three classes, short, tall, medium, in which we need to classify this data. Name is not going to help in any manner to classify. So what are the two attributes which are important? Gender and height, male, female, and the height is what? It is a continuous data. Okay, so if we summarize the data for gender, there are three which are short, six which are medium, zero females which are tall. So in all, how many females are there? 9. Similarly, for males, there is 1 short, 2 medium, 3 tall. You can check it out from this data. So 6 in all. So in all, how many records? 15 records in all. Now, for height, we cannot have it like that. We cannot have similar tables. So what do we have? We divide it into two attributes, less than and greater than. Say, for example, less than, any records which are less than will go in the left subtree, and records which are greater than might go into the right subtree. For example, so less than 1.6 there is no record, greater than 1.6 there are 15 records. So over here this greater than is the inclusive thing. So 1.6 or greater are 15. Similarly for 1.7, what is the case? You have 2 less than 1.7 and you have 13 greater than 1.7. So if we check out, for example, now we'll have to apply the CART algorithm on the basis of each attribute. We'll have to make a split and we'll have to check the CART value over there. So if we split it on the basis of gender, so assuming that we take females on the left hand side and males on the right hand side, so what do we get? There are 3 short, 6 medium and 0 tall over there. Whereas for for males, we have 1 short, 2 medium and 3 tall over there. Okay, so now if we apply the formula, what is the formula? What is the probability that the person is going to be there in the left hand subtree? So twice into probability of the person being female in the left subtree. Left subtree is for female. So probability is going to be what? 9 upon 15. Similarly, probability for it being in the right subtree, the males are there in the right subtree. So the probability is going to be 6 upon 15. So 6 upon 15 into, this is what? The probability that it being in the left subtree, it belongs to class female. Probability being in the right subtree, it belongs to this. So what is the probability over here? What is the case? 3. What is the female probability in the short? 3 minus 1. So 2. 2 divided by what is the total number? 15. Similarly, over here, what is the case? You have 6 medium females and 2 medium females. So what is the case? 6 minus 2, 4. 4 upon 15. Similarly, over here, what is the case? 3 what if female we are considering left and males we are considering right, right? So 0 minus 3 and we are taking the modulus over here, absolute value over here. So 0 minus 3, that's 3. So that's why 3 upon 15. So what is a case if we are bifurcating it as per gender? If you're bifurcating it as per gender, we are getting this as the cart value. A small recap, you have the probabilities of the left and the right subtree. Then what is the probability if the person is on the left subtree? What is the probability that it will be belonging to class female or it will belong to class male? So it is 3 short, 3 minus 1, 2 upon 15 and so on. Similarly, what do? You do it for this height also. Less than 1.6, greater than 1.6. So less than 1.6 and greater than 1.6 from the table, you find out how many of them are of the category short, male and tall, and this is the bifurcation over there. So again you apply the formula, in all how many short are there. So less than 1.6 is going in the right left hand subtree, the greater than 1.6 is going in the right hand subtree. So 2 into 0 upon 15 into 15 upon 50, all of them are in the right subtree only. Now if you divide 4 minus 0, 4 upon 15, 8 minus 0, 8 upon 15, 3 minus 0, 3 upon 50. Similarly, you calculate it for 1.7 also. Similarly, you calculate it for 1.8 also. In fact, you calculate it for all possible values, in the sense you calculate it for gender, you got this value. You calculate it for all the possible values of heights. In this, what do you find? Where are you getting the highest value of the cart over here? It is in this. So the first split which is going to happen in this decision tree is, then the root node itself you will check, is the height less than 1.8 or is the height greater than 1.8. Now you have made the first split. Less than 1.8 people will come in the left subtree, greater than 1.8 are going to come in the right subtree. Again, for all of them you will again proceed in the similar manner. Over here now you will again check the way you were doing it iteratively in ID3. Again over here you will be doing iteratively and you will further construct the tree like this. In the next session, what we'll be doing? We'll be doing Bayesian classification for this. Let's meet again in the next lecture.